Hello, welcome to my channel. In this video we are going to consider a problem in current electricity topic, particularly parallel combination of resistances. Both from physics point of view and maths point of view, we will approach this problem. You are given two resistances, 10 ohm fixed. The other resistance is a variable resistance. You can vary its resistance. It is labeled as R sub X, Rx, indicated by this arrow mark. This indicates this Rx is a variable. What we are supposed to do is show the variation of effective resistance R effective with Rx graphically. R effective means effective resistance of these two for whatever value Rx we have at any point of time. Then that resistance and this 10 ohm, that parallel combination effective resistance is R effective. So first we have to draw the graph which will show the variation of effective resistance with Rx. Then we have to discuss what happens if Rx tends to infinity. This value of Rx, we keep on increasing, and if it tends to infinity, what happens means what happens to R effective. That is understood. What happens if Rx tends to infinity means what happens to R effective. What happens to R effective, that is understood. For that, first we have to use the formula for effective resistance when two resistors here are connected in parallel. Parallel combination. Formula for the effective resistance. R effective is equal to 10 Rx by 10 plus Rx. This 10 is because of the given value, okay? Otherwise, in general, if two resistors are connected in parallel, say R1 and R2 connected in parallel, then we will have 1 by R effective will be 1 by R1 plus 1 by R2, or you can simply write as R1 R2 by R1 plus R2 as the effective resistance formula. But here it is 10. The other resistance is Rx. So 10 Rx by 10 plus Rx is of effective resistance of this combination. We have to draw the graph for that. For that, we will give various values to Rx, calculate the corresponding values, get the ordered pairs, plot it in the plane of the graph. Then you will have to join all the points freehand to get the curve, right? So the graph, we will draw the x-axis and y-axis. Along the x-axis we have to take Rx, along the y-axis we will have to take R effective, Rx. You can even call it as Rx axis, and we will show the graduations. So some suitable values we take and show the graduations here. Similarly, y-axis we will take R effective. So you can even say that it is a R effective axis. Here also we will show the graduations with suitable values suitable to this problem, okay? Okay, now we will give typical values to Rx, get few ordered pairs, plot it in this region, join them, okay? This part indicates that you are short circuiting Rx. That means you connect the two ends of this Rx directly. This is to exclude Rx from functioning. That means whatever current comes here, it will go through this, because this is a path of zero resistance, so Rx will be excluded. So you can take when Rx is 0, I'm going to give various values here, no? So take Rx is 0, means we will have to simply connect the two endpoints of the resistance or disconnecting Rx. Only the ends are connected here. That means it provides a path of zero resistance. So all the current will flow in this path of zero resistance, not even they flow through this 10 ohm resistance. So effective resistance will become 0. So when Rx is 0, R effective is 0. That is achieved physically like this. all the current flows in this part. This 10 ohm may be there, but current will not flow through that. Current chooses to flow in this path. So we can say effective resistance is also 0 when Rx is 0. So first point, Rx is 0 means R effective 0. This can also be explained from mathematics point of view. Put Rx is 0 here, then 10 into 0 is 0 in the numerator, 10 plus 0, 10 in the denominator, so 0 by 10 is 0, so R effective is 0. That is this point, okay, origin, can say this is origin. So in this point, 0 comma 0, okay. Go to the next point, take Rx as 2.5, that is here it is 2.5, 2.5 into 10, 25. 25 divided by 2.5 plus 10, 12.5. So 25 divided by 12.5, which is 2. 25 divided by 12.5 equals to 2. So the second pair is, ordered pair is 2.5 comma 2. Comes here. So 2.5, 2. So that is the second point. First point 0 comma 0. Second point is 2.5 comma 2. Then third value we are taking, Rx is 8. So 10 into 8 by 10 plus 8. 80 by 18, 4.4. You can take as 4.5 also. Little bit this way or that way will not matter much, because we are taking sample values, and the scale we will have to take suitably. So this point is 8 comma 4.4. 8, 4.4. Okay. Then one more point, 10. So we take Rx as 10 here. 10 into 10, 100. 10 plus 10, 20. 100 by 20 will be 5. So the third point, sorry, fourth point, 5. So 10 comma 5. 10, 5. So we have got 4 points. So draw a curve passing through all the 4 points. It's like this. Is it clear? That's how generally we do, even in practical classes. Right. This is the graph. First part is over. The second part, what is it? What happens to RF if Rx tends to infinity? That Rx tends to infinity, what will happen to R effective? That can be explained both from mathematics point of view and physics point of view. First we will take up the mathematics point of view. So when you say Rx tends to infinity, it is limit Rx tending to infinity in this function. Okay. So limit Rx tends to infinity, 10 divided by 10 by Rx plus 1. That means this one is only R effective. Divide both numerator and denominator by Rx. So when you divide 10 Rx by Rx, you get 10. Denominator also you should divide by Rx. So 10 by Rx plus 1. Now you substitute Rx as infinity. That is very high value here. Then this would become 0. 0 plus 1 is 1. 10 by 1 is 10. So the value of the limit is 10. So when Rx tends to infinity, R effective will become 10. Right? So this is mathematically explained like this. But how do you explain it in physics? When Rx tends to infinity here, okay, that means this tends to infinity. That means the value keeps on increasing, tending to infinity. That means current through this will decrease and become 0. Current here, because of high resistance, we can say the current is 0. It is as if this resistance is not there in place. It is as if this part is an open circuit, because very high resistance. So it is as if there is no resistance in this. It is as if there is a very high resistance, very high. So no current will flow through this because high resistance. It is as if it is an open circuit in this branch. There is an open circuit in this branch. Therefore, effective resistance is 10 ohm. Have you understood this? Okay, that is, can explain it using the graph this way. So as Rx is increasing, tending to infinity, it will become close to this line, which is called asymptote. And let's say this distance between the two as d, that is called asymptote. The line is called asymptote. The equation of the line is Rf is equal to 10. So actually, what is an asymptote? Asymptote is a line the curve approaches when its x value tends to infinity. In this case, just x. We are considering only this branch of this quadrant. So we say that as this Rx tends to infinity, this d will tend to become 0. That is, the curve approaches this line. That line's equation Rf is equal to 10, and that line is called as asymptote. Okay, asymptote. We are confining our focus only to this quadrant. Okay, so asymptote is R effective is equal to 10, which is the equation of the line. Right. So how do you say that it is really 10 ohm? I said already, this branch is as if it is an open circuit because very high resistance. We can, let's say, tending to infinity. The circuit is this 10 ohm. So here we say that the resistance tends to infinity. So it is as if it is an open circuit. So only 10 ohm is included in the circuit. So effective resistance is 10 ohm, given both by a mathematical perspective and also by drawing an equivalent circuit and explaining what an asymptote is. Understood this? Thank you.